Okay, so we have this graph. We're going to call this y equals f of x. And what we'll do is just look at some limits and also function values here and investigate what's happening with these. So for instance, let's start with around this value of x equals -3. We have limits they can approach. We can look at as x approaches any particular x value from the left or the right side. So let's look at what happens as x approaches -3 from the left of f of x. What would you say happens to this one? And then also, we'll just list what we want to start out with. Limit as x approaches -3 from the right of f of x. And then we're going to look at the two-sided limit as x approaches -3. And then also, what is f of -3? Okay, so going back to here again, looking at limit as x approaches -3 from the left. So if you're going toward -3 from the left, you're going to start just to the left of -3 and find where your graph is, and that's going to be down here. You can think of following your graph toward as x approaches -3, and what are the y values approaching? And you can see it's approaching this open circle then, and therefore it looks like it's going to be approaching this value of -2. Okay? And then the limit as x approaches -3 from the right. We're going to look just to the right of -3, find where our graph is, and then see what happens as we approach -3 from the right. What happens to the y values, the function values? You can see it's going to be approaching the y value of 1. So the limit as x approaches -3 from the right of this function f of x would be 1. And if you remember from last time, we talked about a two-sided limit would only exist if both one-sided limits equal a finite number and they're equal to each other. So notice these are not equal to each other. So here we would just say that this two-sided limit as x approaches -3 of f of x does not exist. And again, we could use the abbreviation DNE for does not exist. And then f of -3, what is that value here? Yeah, that would be actually the actual function value when x equals -3 would be this closed-in circle here, or that's going to be here at y equals 1. Okay. By the way, if this video is helping, go ahead and give a like and a subscribe. So let's take a look around x equals -1. We're going to do the same thing. Okay. So here, what do we have for limit as x approaches -1 from the left? Just to the left of -1, we're going to go to wherever our graph is, which looks like it's going to be up here. As x approaches -1 from the left, the function or the y values are going to be approaching this open circle. Looks like it's going to be approaching 3. So as we approach -1 from the left, the y values approach 3. Then from the right, limit as x approaches -1 from the right of f of x, you're looking just to the right of -1. Find your graph. It's going to be up here. So as you approach -1, as x approaches -1 from the right, the y values here are approaching +3 as well. And then you can see we have the same finite number, the limit from the left and the limit from the right. So the two-sided limit does exist. It does approach the function, or the graph does approach the y value of 3 from both sides. And then f of -1 is the actual function value there, which you can see actually here is going to be -3. Now you could have, maybe this doesn't even exist. If there was no point here, we could say the function value would be DNE, or does not exist. But we do have a function value just misplaced somewhere else. Well, I say misplaced, but it's just defined somewhere else other than where it would normally be, where the limit, I say normally, if it was like a nice continuous curve here, it would normally be right there and not have a hole there. So if there was no hole, yeah, your function would normally have a value there, f of -1 equals 3. But again, here the function value is defined somewhere else. The limit still does exist, and it does go toward 3. So again, the limit here is not the same as the function value. All right, what about around x equals 1? What would we say here? Limit as x approaches 1 from the left, from the right, and the two-sided limit, and then the function value. Limit as x approaches 1 from the left, what would that be? If you said 4, that's right. We're going to approach 1 from the left side. As we approach 1 from the left side, the graph here is approaching the y value of 4. And then as we approach 1 from the right side, our function value here, we'd kind of be on this graph, approaching the y value there of 4 there. And then the two-sided limit does exist. Both sides approach, from both sides, they both approach the y value of 4. Our two-sided limit will be 4. F of 1, we do have a point actually right there, it looks like, at 1, 4. So f of 1 would be equal to 4. All of these are equal to 4. Actually, in this particular case, we're going to learn later that this is actually what happens when we have a function that's continuous at a particular point. If the limit exists, then this function value exists, then they're all equal to each other. That's going to be continuous. A rough definition of continuous, you can trace the curve without picking up your pen or pencil. So it's just going to be nice continuous curve right through that point. Okay, so now let's look at around x equals 3. By the way, if this video is helping, go ahead and give a like and a subscribe. Hopefully you can answer these before I do. Maybe even pause the video and say what they are, or I'll just wait a few seconds here. What would be the limit as x approaches 3, say from the left side, from the right side, the limit as x approaches 3, and then what would f of 3 be? So from the left side, we're going to be, if you notice from the left side of 3, we would be up on this graph approaching the y value of 2. And the limit as x approaches 3 from the right would be just to the right of 3, and find your graph, which is down here, approaching from the right toward 3. Your y values would be approaching this -1 here. And then, in order for the two-sided limit to exist, the limit as x approaches 3 of f of x, both these one-sided limits would have to be finite and equal to each other, which they're not equal to each other. So this would be does not exist. And then what is our f of 3? That's going to be, well, this is filled in right here at this point here at 3, 2. So we have f of 3 does equal 2. Okay, let's look at around x equals 4. What do we have there? As x approaches 4 from the left side, we're just to the left of 4. Again, you always want to think just to the left of 4. And later on when we do this numerically, we might think of like 3.5, 3.9, 3.999, 3.99999 just to the left of 4, and what happens as you approach 4. So if you go to 3.5, 3.9, 3.9999, the y values you can see just to the left of 4, they're going toward negative infinity right next to this vertical asymptote. So this would be going toward negative infinity. Now technically this is still does not exist. If it does not go toward a finite number, we still consider it a limit that does not exist. But we do describe it typically, if it does go to infinity or negative infinity, we do describe its behavior. So we would say the limit as x approaches 4 from the left of f of x equals negative infinity. Okay, well, what about the limit as x approaches 4 from the right of f of x? What would you have here? What would you say that would be? So if you said positive infinity, that is correct. We're looking just to the right of 4 and seeing what happens to our function. We can see it's approaching the vertical asymptote up here. So if x is approaching 4 from the right, like 4.2, 4.1, 4.01, 4.001. As you approach 4 from the right side, these function values are going up toward positive infinity. Again, technically, this is a limit that does not exist, but we do describe the behavior as going toward infinity. Now, what would we say about the limit as x approaches 4 then? So here, remember, for a two-sided limit, the only way that would exist is if the two one-sided limits exist and are equal to each other. So here, the limits already do not exist, and they also go in opposite directions. So we would just say does not exist here. Now, actually, if these, say, let's just say they both went the same direction. Let's say they both went to a positive infinity. We could still describe the limit as x approaches 4 then as positive infinity here. But again, really, it's still, if it's not a finite number, it still is in the category of does not exist. Okay? So if they do go both to the same direction, if they both go to positive infinity on a vertical asymptote or both go to negative infinity on vertical asymptote, we can describe it that way. Again, still being does not exist anyway, though. And then if we had f of 4, the function value f of 4, what would we have here? Oh, actually, there's no point on this vertical asymptote, right? So this would actually be, again, does not exist, okay? By the way, if this video is helping, go ahead and give a like and a subscribe. Alright, so let's take a look at what happens near 6. So if we look at the limit as x approaches 6 from the left, here we would have, looking at 6 and just to the left of 6, what do we have here? Just to the left of 6, do you see just to the left of 6, we would be up here on this graph, and it looks like it's approaching as we kind of move along that curve. As x approaches 6, the y values are approaching that value of 4. Okay, so we would have here, it's going to go toward y equals 4, or the function value is going to go toward 4. Now what happens here as x approaches 6 from the right side? Actually, if you notice, there's really no domain here, is there? So there's not anything, there is no function value at, say, f of 6.1 or f of 6.01, or just to the right of 6. We're assuming this point here is right at the point, say, 6,4. So just to the right of 6, there's no function value, there's no domain. So actually, if there's no function value, we can't have a limit coming towards 6 if there's nothing there. So this is another does not exist, DNE. And then we have the limit as x approaches 6, the two-sided limit. Well, if one of these does not exist, then the two-sided limit can't exist either. And what about f of 6? Does that, what would we have for that? Yep, we do have a function value right at x equals 6, or f of 6 would be equal to 4. All right. And around 7, that would be a similar type of situation that we did with 6. I'll let you do that one on your own, but let's look at like what happens near this horizontal asymptote then as well. So let's think about what's happening here to describe something at a horizontal asymptote. You have this graph going this way. To describe this, what's happening to your x values as we kind of go toward that asymptote? Aren't the x values just getting bigger and bigger? They're going to go actually to infinity, right? So actually, let's just write that in here. We could say the limit as x approaches infinity of f of x. So the f of x again being our y values. If as x approaches infinity, if you remember how asymptotes work, you're going to have your function values, or your graph is going to get closer and closer to your asymptote here. So therefore, in this case, it's going to go toward the finite value of 1. So you can have end behavior where you have a limit as x goes toward infinity. As x approaches negative infinity, if you kind of look at this graph, your y values are also going toward negative infinity. So if we write that out, we just have the limit as x approaches negative infinity of f of x is going to go toward negative infinity. By the way, if this video is helping, go ahead and give a like and a subscribe.